Okay, so here's a pretty straightforward example of rotating one function about a bunch of different lines. So in the last video we had sort of developed some formulas for rotating about the x-axis, about the y-axis, and then about different vertical and horizontal lines. Horizontal and vertical lines. So let's go ahead and do this. So they give us this function f of x equals negative 1 over 32x squared plus 8. Find the volume when the region enclosed by f in the first quadrant is rotated about these axes. So first thing to do would be nice to get a picture of what we are rotating. So this is a y-intercept of 8, and I already know this because I looked it up. It has an x-intercept of 16 and negative 16, so it looks like this. And so that's the region that is enclosed by the function in the first quadrant. The other half of it comes over here and then it keeps going down, but we really only need that piece of the function. I'd encourage you, when you're sketching these, to only sketch the region that you're revolving. So this is the only region that we're revolving. So if we revolve it around the x-axis, first thing to do would be to reflect, because then we can get a sense for what it looks like, and draw an oval so that we can sort of see what our coin looks like and what our radius is going to be. So because we're revolving a function about the x-axis, our radius is simply the function itself, f of x. And so this should be the integral from our first x value, which is 0, to our last x value, which is 16, of pi times our radius squared. Our radius in this case is just f of x squared, times the little width of the coin, which is dx. So that should be the integral from 0 to 16. I can move the pi out front of the integral because that is a property of integrals. This is my function. So it's negative 1 over 32x squared plus 8 all squared dx. And from there, I'd have to either use a calculator or square this out and use the fundamental theorem of calculus. But this is now a doable problem that's not really volume. Now we're talking about anti-differentiation or integration. So that kind of takes care of part A, which was revolve it about the x-axis. Now part B asked us to revolve the same region around the y-axis. So again, this is 8, this is 16. Now we're revolving that around the y-axis, so it reflects over here. And it's going to create this bowl-looking thing. Right, upside down bowl-looking thing, or I don't know what that would be, maybe a weird like sweet bun or something, I don't know. Anyways, it looks like this. And so now our radius is given by g of y, but we don't have g of y, we have f of x. So we need to solve that for x. So we had y equals negative 1 over 32x squared plus 8. So that means y minus 8 is equal to negative 1/32 x squared multiplied by negative 1 over 32, or excuse me, multiplied by 32, we should get negative 32y plus 32 times 8, which is 256, equals x squared, or multiplied by negative 32, I think. And then taking a square root, we should get that the square root of 256 minus 32y is equal to x. Now I know that I can choose the positive one because these are these are positive x values. The negative one is over here, but I'm using the positive one. It doesn't matter because I'm going to square it, but technically it should be the positive one. So that's now my radius, and so if I'm setting up my integral, it should be pi times the integral from my lowest y value, which is 0, up to my highest value, which is 8, 0 to 8 of my radius squared, square root of 256 minus 32y, all squared, dy. This is actually a much simpler integral. Again, it gives me a different volume. This volume and that volume are definitely not the same. But it's much easier because I'm going to square that square root, and that'll be pretty straightforward. So that's going to be pi integral from 0 to 8 of 256 minus 32y dy, and that'd be a pretty straightforward application of the fundamental theorem of calculus. So here we've revolved about the x-axis. Here we revolved about the y-axis. We had to solve for x to get a function of y. Finally, what about the lines y equals 8 or x equals 2? So I'm going to leave that there so I can use it later, but we're going to erase everything else so that I can draw some pictures. So, first of all, y equals 8. That's a horizontal line. So here is my function again, and I'm revolving it now about this line, which is y equals 8. So this is going up above, and it's going to reflect like so, and it's going to make a sort of horn-looking thing or a trumpet-looking thing, right? And so now I need to figure out what my radius is, having revolved this function f of x up above the line y equals 8. So, basically, we remember that to find this radius, you need to do top minus bottom, and that's 8 minus f of x. This distance is 8. This distance is f of x, so the distance in between is 8 minus f of x. So remembering that this was 0 x value, and this was 16, I should have basically pi times the integral from 0 to 16 of 8 minus f of x all squared dx. And that is pi times the integral from 0 to 16 of 8 minus this stuff, but 8 minus this stuff is actually just negative 1 over 32x squared dx, right? Because the 8 minus the 8 is going to be gone, and this should be positive because I'm subtracting. But again, it's not going to matter because I'm squaring it. Hooray, so that's actually a pretty straightforward integral. So that was c. But now, finally, what if I want to revolve it around the vertical line x equals negative 2? So again, here is my function. Looks like this. This is g of y now. 8. This is 0, 16. No, it's not. It's 16, 0. This is 0, 8. And this thing is now going to get revolved around this line, x equals negative 2. So my radius is there, and it's coming all the way over here, like so. So it's this giant thing. Even at the top, it's this huge thing. Yikes, right? Huge, huge thing, right? Stretching that axis added this whole thing in the middle, right? A big, big piece in the middle. This is one giant, solid, cake-looking thing. I don't know what it looks like. So, now my radius is this whole thing. Instead of just g of y, it's g of y plus 2, right? I've added an additional 2 on. But that is the same as g of y minus a negative 2. I like to always do right minus left, so right minus that is going to add them because one of them is negative. And so your integral should go from your bottom y value, which is 0, all the way up to your top y value, which is 8, of pi times your radius squared, and your radius is g of y, which was the square root of 256 minus 32y, plus 2, all squared, dy. So now we've seen an example of rotating about the x-axis, the y-axis, y equals 8, and x equals negative 2. A different horizontal line above, and a different vertical line to the left. So those are all the possibilities, really. Practically, there's a couple more that are very similar for revolving one function about an axis. And so what we want to look at next is what happens when you revolve two functions and cut something out of the middle.